So our theme this year, by the way, is quality intelligence. So Moss, I thought, is that why you put all these brains up here?
That's sort of why I put some brains on there. Yeah, some cogs.
Great. Well,
Brain cogs.
metaphor for the agile mindset. Thanks, Moss.
Oh, there's. I apologize because mine's going to take at least 10 minutes, and I'm going to be in trouble from Phil for that. I'll start it right now. Okay. So I was trying to think of, actually this talk was slightly different to start with, and I was thinking, what problem am I really trying to solve, just like Phil was talking at the beginning. And I realized that the problem that I was trying to solve is talking about what's the hardest thing in developing software for business. And so I Googled that, or used DuckDuckGo, and it showed up. And one of the first things that showed up was this post from Martin Fowler. And he is the author of Refactoring for refactoring software. And he also has this is kind of his wiki API, he calls it. There are only two hard things in computer science: cache and validation, and naming things. And this is funny for a variety of ways. I'm not going to explain the joke, but I mean, one is very specific and one is so generic that, that starts with that. And it's from Phil Carlton it's a quote from the early 90s. That one goes into some other riffs on that. There are two hard problems in computer science: cache and validation. Naming things and off by one errors is one. That's one that I like a lot. And then this is for the network people. There are only two hard problems in distributed systems: exactly once delivery, guaranteed order of messages, and exactly once delivery. So anyway, the hardest thing in developing software, this is talking about computer science or computer networking, a lot of things. I'm thinking about business. And I think the hardest thing about developing software for business systems is communication. And it's kind of funny that Phil must have been on a similar wavelength. He was talking a lot about communication in his introduction. Talking about abstract ideas is really hard, and pretty much, 95% of what we're talking about in software is abstract ideas. What's the value of automation versus exploratory testing? Or, how many people in here have ever had their manager say, "Why is software development so slow?" Or if you're having a technical discussion, you have to say, "This is an elegant solution," and somebody will say, "No, that's a really bad solution. It's not elegant at all." And so you have to talk about these things. What does elegant mean? One thing that I had on here, but I didn't have enough screen space, was cybersecurity. And you can hear from two of the previous talks that cybersecurity in itself is a very complicated thing to communicate. So the question is, in communication, how do you keep from doing this hard? Let me go back one and talk about Carl Wiegers, who has been at PNSQC for a couple of times. His real thing is talking about requirements. He's written multiple books on it. It'd be about 13 inches thick if I stacked up all his books. And a good long conversation is, when are requirements good enough? And you don't want to have that conversation every single time somebody says, are these requirements good enough? You want to have some sort of easy way to bring something to the conversation, say, yes, we're about 12 inches into the requirements, we're good enough. So the question is how to communicate with agility, how to keep from doing the hard work over and over, and instead bring some context and simplicity to what the topic that you're talking about. And you want to make sure that the method of communication does most of the heavy lifting. So if I'm talking about, for example, in computer science or in computer architecture, you might talk about things like a scaffold or a builder or a facade. When you say, write a builder, a lot of people will understand what you mean by that. And then you won't have to explain from, patterns of computer architecture, computer software, what a builder is. So you can just bring that there. Same thing with, other ways to communicate ideas. So keeping it simple. In software, at PNSQC, I hear a lot of people talk about models. And this is a shout out to James Bach or John Bach, who was going to be here and then he couldn't speak tonight. But I've heard him and his brother James Bach talk about all models are wrong, but some are useful, which is kind of a funny quote by George Box. And George Box was talking about statistical modeling. But really, when we're working on software, we use models all the time. You know, the models are a simplification of reality. Most of the time, they're pretty useful. When you have a useful model, you can actually use that to make decisions and predictions. And also, once you have a model, like I put something out there and I say, this is a facade, you kind of understand, same as a facade on a building, this is some sort of big interface to this software system. So also similar to models, Agile coaches talk a lot about games and simulations. And this is a book that I really like, Game Storming. They have a bunch of games in there, and some people might hear games and think, or games in Agile and think, oh, this is not real work. This is just playing around. We got to get into the real stuff of writing hard requirements. But really, these games are a way to engage people and bring them into a simple system, a model of something that happens during the business activity. And a couple that they show here, like the speedboat, which is a way of thinking what's pushing you forward, what's holding you back from moving more quickly. Or, for example, the one game that they have that I like is called Draw Toast. And really, you're just drawing all the steps in making toast. You discover once you get that out of your head and into a shared space that there are a lot of things that you're not thinking about that other people are thinking about. So you can share this model. So let me catch up on my. So really, all those things are game simulations and models are all metaphors. And so metaphors compare two concepts that at first seem unrelated, but they actually have, there's a connection between them that makes it more concrete and easier for you to understand. For example, some written metaphors. All the World's a Stage by William Shakespeare. The world is not actually a stage that you're standing on, but in a way, everyone is performing. Love is a battlefield. Hopefully, it's not an actual battlefield. We talk about in business the elephant in the room. If there was actually an elephant in the room, it would probably be a lot stinkier room than here. But hopefully, when you're talking about an elephant in the room, it's actually a big stinky problem and not a big stinky pachyderm. And one that I like that's a metaphor is hope is the thing with feathers that perches in the soul by Emily Dickinson. I mean, it's a elegantly phrased metaphor, and it doesn't say, doesn't say like or as. It just gives you the feeling of what hope might be without saying anything, too specific. It's more like comparing it to the bird. Also, I wanted to point out the visual metaphors on the other side. Here, there's iceberg is a good metaphor for a lot of things. In this case, it's a system thinking diagram. And then also there's the Agile test pyramid. And, your tests are never actually in a pyramid stacked up. That would be unwieldy. But it's an idea to say, okay, you should have mostly a base of unit tests and then work through these other tests and get to a fine point of automated GUI tests. And then, maybe a very small set of kind of exploratory tests at the top. So thinking about metaphors, I'll come back to this and repeat it again, but hopefully another reason that we have a brain there is that a good metaphor changes the way that you actually think. It reshapes how you perceive and understand what's going on. It'll take this abstract concept and make it concrete. And so, by doing that, it also engages you, shifts your perspective, and can help you challenge the assumptions. So now I'm a little bit crazy for this. We're going to do a lightning talk exercise. And so you guys have 30 seconds to do some planning here, and then 1 minute to actually implement this metaphor that we're going to do. And this is called the ballpoint game. It's a metaphor for Scrum or for Agile software development. And so the rules are everyone at each single table, you guys are a team, so look at your team members. You can't pass the ball to your direct neighbor. You have to toss the ball to somebody that's not next to you. The ball must catch air. It has to be tossed. If you drop a ball, you can't pick it up. And the goal is, like at work, to complete as many, think of these balls as tasks, complete as many tasks as possible. And so your definition of done is all team members must touch each ball, and that's good enough. So here, I'm going to start planning for 30 seconds. First, you guys at each table, write down, there are a bunch of sticky notes in front of you on the table. Write down on the first sticky note the number of balls that you'll complete. I want you guys to estimate that. And you have 30 seconds starting now. You want to get, I'm at 10. Okay, I'm your software development manager, and I need an answer right now. Okay, did you guys write down the answer? When your sticky notes are also going to act as your balls. So grab a sticky note and crumple it up and start tossing it. And we're going to start the sprint right now, and you have a minute for that. So start. For the people that are remote, there's actually a remote way to do this, a work from home kind of version, but I didn't get that ready in time. We're halfway through the sprint, by the way. Did you toss the ball to somebody that's not next to you? Oh, works better if you have 4 people, doesn't it? Yeah. Okay, our sprint is now over. And the main question is, how many people actually reached their goal of getting the number of tasks done that they estimated they're going to get done? Doesn't they get a counter? Did you guys, does anybody have any immediate insight? Any insights here? So I'm guessing that some of the insights that we may have learned is not enough time, estimation's hard, not sure what we're working on. The handoffs are a chance for errors. We had some bottlenecks. We started out with a leader, and this is or is not like software development. I think it is like software development in that you have a bunch of balls up in the air at the same time and nobody knows what's going on sometimes. So the other question is this a good metaphor? Did it change the way that you might think about software development? In an ideal exercise, we'd actually do this about 5 times and reiterate. People would get better at practicing what's going on and understand. And maybe you'd reduce your handoffs and get a leader and get better at things. This metaphor, it did simplify the complexity of software development. It makes the abstract idea of software development more concrete. It did bring some emotion to it. I don't know if it shifted anybody's perspective, but it helps you get a little bit more empathy with people in the software team. So I wanted to just bring the reason that I wanted to talk about metaphors is because in software development, we're always creating models. In fact, I'd say even more than 95%. Mostly what we're doing is creating software that models the real world, and communicating these models accurately from the real world to the software system is imperfect, like George Box said, but hopefully by using well-constructed metaphors, we can communicate these big abstract ideas in a high bandwidth way that will make the quality of the software or the model a lot better. So that's all I have to say. Thank you. And I know I went over, sorry.